Minasan, konnichiwa, Zamurai Engineer desu. In this video, we will show you how to analyze, first solve, tabulate the result, and analyze an actual problem, an actual given problem. So we will use our calculator. So please prepare a ball pen, paper, and calculator. Let us proceed with an actual analysis of how step size affects our result, our computation of what? The first derivative. Okay? We are approximating the first derivative of the function by using numerical method. So let us do it. Okay. So as you can see, the given function here is 9e to the 4x power. And we are being asked what is the first derivative of that function at x is equal to 0.2 using forward difference method. We already know that forward difference method is what? Is the method wherein it defines slope or the first derivative as equal to fx plus delta x minus fx over delta x. Okay. For example, let us start with delta x is equal to 0.05. As you can see in this table, that is the first number here, 0.05. That is x, which means it is also delta x. Okay. Okay. So let us proceed with finding out the slope. We can easily find out the value of the function by using our calculator as we have done on our previous video. But now, you would like to solve the problem by finding out the first derivative using forward difference method. So we need 2 points. What are the points? X is equal to 0.2 and x is equal to 0.25. Why 0.25? Because delta x is 0.05. So x plus delta x is 0.25. Okay? Take note about that. Take note. So there are two values that we would like to evaluate this this function. This function, let us evaluate using 0.25 and also using x is equal to 0.2. So there are two values. So f of x is equal to 0.25, wherein x is equal to 0.25, minus the same function wherein x is equal to 0.2. Let us subtract. Then divide by delta x, wherein delta x is 0.05. So simple as that. That is the slope. So let us proceed. Now I will share the calculator. Okay. Remember the function and remember the given. So you can what? You can copy the given. You can screenshot. Okay. So I will share the calculator. So let us proceed. So clear. So the numerator is actually the function. Okay, the numerator is the function which is 9, okay, which is 9 times E, okay, okay, sorry about that. 9 sheep, press the sheep and E here. This is the E. Okay. Times 4 times what is X plus delta X? 0.25. Okay. Times 0.25. Okay. Then that is what? Close parenthesis. This value is Fx plus delta X minus Fx. Okay, what is Fx? That is 9 times E to the 4 times, what is our X? Our X is 0.2. Okay, 0.2. That is our X. Actually, let us put on the parentheses, and then just put on the parentheses divided by delta X. Delta X is 0.05. 0.05. So this is actually what? Forward divided difference method. So let us find the result. The result is 88.69336. Okay, take note of this. Use your calculator. The result should be 88.69336. Okay, let us show you the okay. So 88.69336. The same. Okay, same. And we can calculate the absolute true error. Okay, we can compute this. Okay. Okay, so absolute true error. That is the one important to us. So this is what? Significant digits. Okay. It shows which digit up to which digit is correct. So this one shows up to which digit is correct. So you cannot say any digit of the answer as correct. You cannot say. So this is not yet the answer. No. Okay. So let us proceed to the next. What is our concept? If we get an answer which is not yet our acceptable answer, so let us what we'll do? Let us have meaning divided by 2. Let us have the delta X, or let us have the H here. So 0.05 divided by 2, that is from your calculator, 0.05 divided by 2, that is 0.025. Remember that our delta X is 0.025. Okay. Again, let us proceed with the same computation. So we will compute this first, huh? Absolute. Okay, so what is our if we take the first derivative of this by using calculus, the answer is let us show. Let us show by using calculator. Our if we use the calculus, if you use calculus to find the first derivative, what will happen? Taking that derivative of the function 9e to the 4x will become what? 4 times 9. That is what? 4 times 9 times e to the 4x. Okay. X is 0.2. Okay. So the value we are looking for is actually 80. But our answer is 88.69336. So it is very far. So take note, if you have this calculator, you can save this value. Let us save this value. Store by shift, store, and then press A. Here, A. So the value is stored in alala. Okay. Repeat. Let us find out 4 times 9 times e to the 4 times 0.2. This is 80.119. No? So let us store. Okay, take note. Please go with me. Press shift, store, then A. Meaning our answer, which is 80.119, will be stored in memory A. So that is our. So if you can see, we have a memory storage. This calculator has memory storage. You want to recall the value in the memory A. So you can, okay, A, what is inside A? 80.11947. Okay, so that's how you store value to the memory. Okay. So how many memory does this calculator has? A, B, C, D, E, F. There are 6, 7, 8, 9. There are 9. Storage memory here. There are 9. So A, B, C, D, E, F, X, Y, M. There are 9 memory space. Okay, so we use A. We only use 1. So it's okay. And our calculated value is what? 88. We calculated the value 88.69336. Do you remember? We computed the value using forward difference method. This is the value using forward difference method when our delta x is 0.05. Okay, so let us store this value inside B. Okay, so our what? Our B memory, there is a value inside which is 88.69336. Okay? That is the value of our first calculated value. Okay? So therefore, in order to determine the absolute, what's that, absolute true error, we can use what? True value, the true value, that is alpha, or you can what? You can use this minus b, a minus b, divided by a. Why a, sir? Because a is the true value. Why true value? Because a is the value we calculated if we directly use calculus. So take note, calculus answers are exact. Or since calculus is exact, that is what? There is no error. So that is the true value. That is the true value. Okay, calculus computation. Our estimate is 88. The true value is 80. So what is the absolute true error? So let us multiply by what? 100%. Even though we don't have to multiply by, let us just press equal sign. So the answer is 0.10701. So therefore, our absolute is positive, because absolute value is positive. No? Everybody will become positive. So, and if you multiply by 100%, how many percent is our absolute true value? 10.701. Okay, and actually, I will show you that is the actual answer on our example here. 10.701. Okay, 0138. That is our answer. Okay, now let's go to the next line by dividing our delta x by 2. Meaning, let's have the delta x. So we make the step size smaller, okay, so that our answer would be more precise and accurate. Okay, so let us do that. Okay, let us share our calculator to show you how to do it. Okay. So let us find out the value of the function at x plus delta x. But now delta x is half. It was 0.05 before. Now it is 0.025. Okay, so let us do that. So that is 9 times e to the 4 times x plus delta x. X is 0.2 plus 0.025. So 0.225. It will become 0.225. Okay. Now let us minus it with the value of fx. The value of fx is simply e to the 9 times e to the 4 times x, not x plus delta x, so times x only. So that's the value of x, 0.2 times 0.2. And let us close the parentheses and divided by delta x. Delta x is 0.025. 0.025. And what is the answer? The answer is 84.2623. Okay. So our first approximation is 88. Now it become 84. And the actual value is 80. So we are going nearer. Okay. So what is now the absolute relative error? What is the absolute relative true error? Okay. So therefore, let us subtract 80. So let us what? Put this inside store it inside the B. Okay. So therefore, let us proceed with computation. B minus A divided by A. This is the formula. This is the formula for what? For absolute relative error. If you want in terms of percent, you have to multiply this by 100. Multiply this by 100. So put 100 here so that it will become in terms of percent. And then press equal sign. So now it is better. Previously, our absolute relative true error is 10.1%, 10.7%. That is a big error. Now it is only 5.17, barely over 5%. Okay. So that's how we compute this. Okay, let us again compute. So still, we don't like the answer. So let us again have the delta x or divided by 2. So 0.025 divided by 2, what is the answer? 0.0125. Okay, take note of that. Huh? Take note of that. Our delta x is 0.0125. Okay, so let us continue. Let us continue. Let us continue with our computation. Okay. Therefore, again, 9 times E raised to the 4 x plus delta x. X is 0.2. Delta x is 0.0125. So times 0.2125. So that is the value of x minus 9 E 4 times 0.2. That is our numerator, and what is our denominator? Delta x, and delta x is 0.0125. And equals, the answer would be 82. So from 88, 84, now it is 82. Okay? Can you see the trend? Can you see the trend? By having our delta x smaller and smaller, the estimate is now from very rough estimate going to more and more accurate estimate. So if we take so let us store this again into B. Okay. Okay. So let us store. So we have 100. Let us find out, compute the what? The absolute relative true error. That is alpha B minus alpha A close parenthesis divided by alpha A. The answer would be, look at your given. Look at the table. Did you screenshot the table? So you can check that the answer would be 2.542193. Okay. Okay. Still, we are not satisfied. Still, we are not satisfied. Okay. We're not satisfied. $2.521. Okay. It is absolute relative true error. You can also compute the epsilon A in order to find out how many significant digits do we need. Okay, so that is also important. Let us go to the next. We are not yet satisfied, so please divide by 2 the delta x. So the delta x is 0.0125. If you divide it by 2 again, what will happen to the delta x? That would be 0.00. There are now 2 zeros. 0.00625. 0.00625. Okay, let us do that. Okay. Practice. There are other ways that we can use this calculator faster, but that is a calculator technique. Later on, I may be able to teach you about that, but currently I am teaching you the actual solution of the problem. So let us first forego with the other things in mind. Let us focus on using this calculator and solving our problem. So let us do that. So therefore, let us again use the next value of delta x. What is x plus delta x? Another value is 0.20625. That is now our new value of x plus delta x minus fx. What is fx? 9 to the e to the 4 times x, which is x, 0.2. So therefore, we have this numerator divided by the denominator, which is delta x. That is 0.0062 and 5. Equal sign. The answer now is 81. So from 88, 84, 82, 81. We are now on the 81. Okay? And our goal is 80. Our goal is 80. So we have now 81. So let us store this result into B. Okay. Okay, we have an 81. What is the value of true? 80.11. 119. So we already have 81. So what is the absolute relative true error? 100 times B minus A divided by A. So equal sign, that is 1.26% error. From 10% error, become 5.1, become 2.5, and now 1.26%. Okay. It is very fast. It is now actually, previously 2.5 is already acceptable because it is less than 3%. Now, it is even more acceptable because it is only 1.26% error. Okay, but anyway, we can still continue computation. Now, for example, we don't yet allow this level of answer. So let us divide delta x by 2 again. So 0.00625 divided by 2, the answer is 0.003125. Okay, 0.003125. Okay. So therefore, let us calculate. Same thing. 4 times 0.2 00 3 1 2 5. Okay, that is our x plus delta x. Now we need to subtract 9 to the e for x. And what is x? Times 0.2 is x. And that is the numerator, and divided by the denominator, which is delta x, which is 0.003125. And what is our answer? 80.6. So 88, 84, 82, 81, and now 80. So our true answer is 80.119. Okay, 80.119. So this is very near, but still could be improved. Still could be improved. So 80.6. Okay, so let us store this value B. Okay, let us find out the absolute relative true error. Absolute relative true error divided by A equals less than 1%, only 0.63%. Less than 1% error, 0.63%, 0.6276. Okay. If we are not yet satisfied, Let us again divided by 2, the delta x. What is delta x? 0.003125 divided by 2. That is 0.001563. 0.001563. Okay, so take note of that. 0.001563. Okay, let us go again to the evaluation of derivative. That is 9e4 times 0.20003125 or 1563. 1563 minus fx. What is fx? 9 4 times 0.2. That is numerator divided by the denominator, which is 0.0031563. 1563. So equals that. So the answer is 80.37. So the answer is 80.12. This is 80.36. So it is closing in. It is closing in on our true value. Okay, let us find out the absolute relative true error. So therefore 100 times B minus A divided by A. The answer is less than 0.5% error. Imagine that. That is only 0.31 error. 0.313. 0.313%. Okay, that's how small this is. Repeatedly divided by 2, divided by 2. What is the value that we want to divide it by 2? The delta x. Meaning, if we divide by 2 the delta x, meaning our points will become closer and closer to each other. The 2 points will become closer and closer. And since the 2 points are become closer and closer, our approximation will be closer. Approximation of what? Our approximation of this slope will become closer and closer to the correct value. So as you can see here, so we are now here. We already calculated 0.313. Okay. So up to this point. So it is your practice to calculate similarly from here to this point using your calculator. Calculate the absolute relative true error. So from this point to this point. So 1, 2, 3, 4, 5. And also what is important is here. So our answer is 80.37. So 1, 2, 3, 4, 5. So there are 5 succeeding approximation, and then also 5 succeeding value for absolute relative true error. So there are 10 computation practice or exercise. You have to use your calculator. Okay. While you have to do it now, or depending upon yourself, you can do it later. Let us proceed with our effect of the step size forward divided difference method. So as you can see, this is our approximation. Our first approximation is 88, more than 88. Then we have what? Second approximation is 84. Then what? 82. Then 80, 80 something. Okay. So you will notice this is the what? Graph of the problem. Okay. What is that? Number of times step size was divided by 2 or half. Okay. And this graph is versus the slope at point 2. Okay. So therefore, we have this graph. Now, what can you say about the effect of step size on approximator? Okay. Number of times step size half, meaning it become 1/2. Number of how many times? Become 1/2. So absolute approximate error. So for our approximate error, it is what? Getting smaller and smaller. Initial step size is 0.05. The error is what? Too much. 88. Our target is 80. So 8 points. That is a very large amount of error. Effect of step size on absolute relative approximate error. Okay. Absolute. So also it becomes lower and lower. Okay, so meaning to say, not just lower, the interpretation would be our answer would be continuously getting to the actual correct value. And effect of step size on least number of significant digits, correct? Least numbers, we are only here. So, okay, so least number of significant digits. So our answer is actually not yet too much, not yet too accurate. We are just here. Up to 2 significant digits, we are here. So up to 2 significant digits, 2, meaning 8 and 0. That is the correct. 8 and 0 are the correct significant digits. 80. So what we are having is the correct answer is 80.6 80.119, and our last approximation is what? 80.37. So very small, no? Very small. There are two significant digits, correct. Step size on true error. Can you say about step size on true error? So as the step size becomes smaller, the true error exponentially become negligible. Okay. Okay, so that is our effect of the step size on true error. And last, effect of step size on absolute relative true error. So this is the value that we always compute. Absolute relative true error. We are always computing, and we observe that it is going nearer and nearer to the correct value, which is 88.119. So those other data in the table, you should be able to calculate. The rest of the numbers in the table should be able to calculate and put it in our comment section. That is your attendance. And if you have any other concerns, please use our comment section below. Okay. Any question? Again, this is Dr. DrEYPEI, preaching engineering for nation building.